Hi class, I was asked to make a quick video about problems 29 and 32 in chapter 10. Both problems are basically the same. They just have different numbers, but they're the same type of problem. This is a maximal type of problem. A max. What we do is we try to maximize the flow through a series of pipes or channels or roads. Um, that's all we're doing. So think about the easiest example is to think about a city planner trying to figure out how to create roads to make sure that cars can go through the roads and not back up the streets and etc. Right? So this is one of the applications, but there's so many more applications. This is a logistics application. This is a any type of process where you're trying to move things from one place to another, like a factory. It would be the same thing. How long it takes in one place, how long it takes in the other place, how many you can do in one location, the other location, and the goal of all the maximals are to pump as much stuff through the system as possible, right? Also, clearly, it's very useful for if you're trying to push some kind of liquid through pipes. You're thinking, what are you talking about, pushing liquid through pipes? Well, I'm talking about the pipes under our cities and towns. I'm talking about oil ducts, gas, even gas, right? All those pipes. How do you transfer that amount of power? You can do it with electrical. How much can you? How do you do it? How do you build your grid so you can push all of the electricity through the grid? This is exactly how it's done. This is the process. Okay, so in the first problem, sorry, let me just take a look at it because I forgot if there's the north-south, yeah, this number 29. The north-south highway system passing through Albany, New York can accommodate the capacities shown. So this is a highway problem. So we have Albany, New York. Okay, so this is Albany, New York, and we have an entrance to the city here in the north and an exit in the south. All right, number 6. So one assumption that we always make is that, which is kind of silly, but it helps, is that everything that goes into the system here at node 1 has to come out of 6 and then technically goes back in. You're thinking, that is very stupid. Why would you want a road system that where cars go in and then come out and go back in? What is this? Bumper cars or a go-kart track? No, it's just that we make the assumption that this doesn't happen just once a day, that this happens over and over and over and over again. So we make the assumption that these cars can go around and back into the system. Obviously, it's not the same cars, it's new cars, but it doesn't matter. Although in some problems, it would be the same vehicles. If you're thinking of, for example, some type of like a cooling system, where it's an enclosed system where the liquid travels through through all the components in the engine, et cetera, whatever that is, or a plane, whatever that is, and that liquid goes through the system, cools down the engine, comes out of the other end hot, goes through the cooling process and goes right back into the circuit and runs through the engine again to cool it down and over and again and again and again and again. Actually, kind of like an AC system will do that as well. It just, I don't know why I'm talking about that. I'm sure I'm putting you to sleep with that, all that stuff, but it works the same way. Okay, so this is how you do it. All right. Usually, I usually put the final piece, the final at the end. That would make sense. But in this case, I put it at the beginning. I don't know why. But it doesn't matter where you put it. You just have to be very careful down here that everything lines up. All right. So by that final piece, I'm talking about what happens after 6. So what happens after 6 is they go back into 1. Therefore, I have x6 1. That means whatever goes from 6 to 1, and is what I just said is that it's all those vehicles that go right back into the system. Okay, That's what you're trying to max out. That's the component that you're trying to max out, the final one. Okay, so just gonna put it there at the top, x61, and you put a 1. Okay, that's it. All right. Now we go back to the beginning. You look at node number 1. Look, what is node number 1? Intersection number 1. This is a highway, a road system. Also, this is like a traffic light. What is traffic light number 1 connected to? It's connected to 2, 4, and 3. Look at the arrows where they're pointing. 2, 4, and 3. Okay, so I write x from 1 to 2, x1 to 3, and x1 to 4. You see those? I'm going to delete these numbers here so they don't confuse you. Out. See those 3? So those are the connections between x and the others. 1 to 2, 1 to 3, 1 to 4. Okay? And you're going to put zeros underneath. That's it. That's how this is, this is a model. Okay? Then go to 2. What is 2 connected to? Well, 2 is already connected through 1, 2, but you already have that one, so you don't have to repeat it. But then 2 is connected from 2 to 5 and 2 to 4. Okay? So there they are. 2 to 4 and 2 to 5. 5, 4. You put them there, and you also put 2 zeros underneath. All right? Then you look at 3. This is painful, right? You just have to make sure that you don't miss anything. Okay, 3 is connected to 4 and 6. I see the arrows, right? Okay, 3, 4, 3, 6, and the 2 zeros. You move to the next one. 4 is in the middle, so it's connected to a lot of things. Let's take a look. 4 is connected to 2. You see this arrow pointing there? So from 4 to 2, from 4 to 3, from 4 to 5, and from 4 to 6. So 4, 2, 4, 3, 4, 5, 4, 6. Those are all the connections, right? You're only looking right now at per each node which arrows go out. If you do that, you won't miss any. Okay? And then finally, 5, 4, and 5, 6. So from 5, you have an arrow pointing at 4, and from 5, you have an arrow pointing at 6. 5, 4, 5, 6, and you put all the zeros underneath. Okay? Now, your sum product is a conventional sum product. You multiply all of these numbers by all of these numbers. Nothing different here. So far, nothing is different than a typical solver. Later, something very different. Okay. Now, we go down here. So constraints, let's see, constraints 1 through 6. Think about these constraints as, this is the map. You are going to explain to solver the map, how things are connected. Okay? You're not telling solver anything about the amount of vehicles or anything. You're just trying to tell solver, these are the ways you can travel through this system. Okay? Which ways are one way, which ways are not a one way, which ways you can go through and which ways you cannot go through. Okay? So, the idea here is this principle, and you can look it up on page 450 or 451, something like that on your book. The idea here is that every traffic light, every node, every point on this map needs to be empty at the end, right? You cannot have vehicles just waiting there while every other car goes through. Okay? They have to be zero. Everything that goes in, right? The vehicles that go in minus the vehicles that leave minus the ones that came in, it has to be equal to 0. And that's, I think the book closes is the flow out minus the flow in must be equal to 0, right? I mean, think about a traffic light. If 5 cars left, that means that 5 cars came in, and that has to be equal to 0, right? You cannot have more cars leaving the light than cars came in, and vice versa. that cannot happen, right? Because how could you have more cars leaving than the cars that came in? It's not possible, right? So that's what you're that's what you're telling Excel. So for the first one, constraint number 1, what you're saying is the cars that leave from 1 are equal to the cars that came into 1. And what comes into 1? Well, what comes into 1 is this, again, this idea from the beginning that everything that comes out of 6 comes around and around and goes back into 1. Okay, so you're going to put a 1 for x12, a 1 for 13, and a 1 for 14, these 3 right here, right? Because what we're saying is, okay, the cars that leave from 1 to 2 and 1 to 3 and 1 to 4 minus, so we put a negative 1, whatever came from 6, 1, that has to be equal to 0. Okay, let me delete these 3. Okay, that has to be equal to 0. Whatever leaves 1 must be equal to whatever got to 1. Let's do another one. Constraint number 2. Okay, so we're looking, all right, so let's see. 2, 4, and 2, 5. Yes, those are the 2 connections that we have. Okay. Okay, this one's going to be a little more tricky because we have 4, 2. Okay, good. So you have leaving 2, you have vehicles going from 2 to 5 and from 2 to 4. So you put 2 1s there. See those 2 1s right here under 2, 4, and 2, 5? Okay, those are the cars leaving. Okay. What came to 2? What vehicles came? What was the inflow into 2? Well, cars came from 1, 2, right? Because they came from 1 to 2. And then we also had cars coming from 4 to 2. So what left must be equal to what arrived. That's why we have these 2 positives and these 2 as negatives. See that? All of that has to be equal to 0. So that's all we're saying, that whatever left 2 must be equal to whatever arrived at 2. And from 2, we have things leaving from 2 to 5 and from 2 to 4. And then coming in from 4 to 2 and from 1 to 2. So that's why we have them, the inflows, we have them as negative and the outflows as positive. Okay? And you keep doing that. It gets tricky. I mean, once you get to 4, right? This one is the worst because 4 has, let's take a look. 4 has outflows from 4 to 2, from 4 to 3, from 4 to 5, and from 4 to 6. So all of those are going to be 1s. Let's take a look. There they are. From 4 to 2, 4 to 3, 4 to 5, 4 to 6. Yes, okay, those 4. And then it has inflows from 1 to 4, from 2 to 4, from 3 to 4, right? I'm looking at the arrows. And from 5 to 4, okay? So you put negative 1s, 1 to 4, 2 to 4, 3 to 4, and then 5 to 4, this one here. All right. So you keep doing that, and you build the map. That's the map. It's just a map. It just tells Excel, ooh, that's horrible. It tells Excel which way it can send the vehicles down, okay? I'm looking for it. All right, that's the map. Then the next one is actually kind of easier. The next one is going to tell Excel, now that Excel knows which direction the vehicles can travel, you need to tell Excel how many vehicles can travel. How big is the pipe? How big is the road? How many things can go through at a given time? So it's quite simple. You go one by one. So you start with 1, 2. Start with with the first one. 1 to 2. From 1 to 2. And you put a 1 there to tell Excel, this is the one that I'm looking at. Okay? Don't ignore the others. I'm just telling you that from 1 to 2, you cannot have more than 2 cars. You see? 2 or 2,000. I guess this is 2,000, right? This must be in thousands. You see how we have that number 2 there? That's what it's saying. That arrow is telling us that the capacity of this connection is 2. Okay, so X12 has a maximum capacity of 2. X13 has a maximum capacity of 6. Okay, so I put a 1 there, and less or equal to 6. What's the next one? 4. Okay. Well, the next one will be 1, 2, 1, 4. Yeah. From 1 to 4, it will be 3. See? There it is. And you just go 1 by 1 by 1 by 1, and you just keep doing that. See how that goes? 1, 1, 1, 1, 1, 1, 1. And just you put the capacities. Okay? Notice, we don't have anything here. I don't know if you noticed that. For the final node, there's nothing. Because we don't know. That's what we're trying to find out. What's the maximum capacity that we can put through this thing? That's our goal. Okay? And then everything else is the same. You build your, just build your solver, your LP, build it the same way. Now, when we get to solver, let me get the solver up. Okay. I just had a warning and I don't know why. Let me see. There might be an issue. Okay, I think it's fine now. You set your objective. Here's your objective. To the max by changing which cells. C19. P19, okay. All right. Given these constraints, which are down here, right? We have, I'm having a little bit of an issue there. Okay. We have all of these equal and all of these less or equal, right? Let me get the solver back out. Okay. Okay. And then, everything else is the same. You hit solve. And that's it. You got your answer. 9. I think it's 9,000. I guess that's the, I just keep forgetting what the question was. Sorry, I'm looking for the question on the problem, on the book. Can the highway accommodate 10,000 vehicles per hour? The answer is no, it can't. The maximum it can accommodate is 9,000. So in this case, no, you cannot have 10,000 vehicles go through. You can only have 9,000. Okay? That's 29. 32 is the same. 32 is the same idea. You identified first the linkages, the roads. In this case, this is a pipeline, right? Yeah, this is the high-price oil company owns a pipeline network that is used to convey oil from its source to several storage locations. A portion of the network is as follows. Okay, and it gives you the network of pipes, and you're pushing oil through these pipes. And you have the source, and then you have the final, and those are the capacities for each of those lines. And you do the same process. Notice here I move the final node, the final point. I move it to the end, but it's the same idea. It doesn't matter. But you make the connections again. So from 1, you can go to 2 and to 4. Okay, so I have 1, 2, 1, 4, and I put 2 1s there, right? From 2, I can go to 3, and I can go to 5. 2, 3, 2, 5, and I put my 2 1s there, right? But then from 2, right, I have things going into 2 from 1, from 3, and from 5. So I put a negative 1 to 2, a negative 3 to 2, and a negative 5 to 2. And remember, this is because at the end, you need to have a pipe that is, you need to have a node that is empty, meaning whatever came out was equal to whatever came in. That means that there's nothing left, all right? And just keep doing the same thing. It's the same problem. And then you have your capacities where you tell Excel, now that I told you the map, now I'm going to give you the capacities. So the capacity of 1 to 2 is 6, right? The capacity of 1 to 4 is 6 as well, etc., etc. And that's how you do those problems. Thank you.